In this video, we're going to be learning how to make distribution plots in Tableau. So remember, the purpose of any visualization type in this family is to show how the observations of a particular variable are distributed across that variable's range. Are they clumped in the middle? Are they spread uniformly across the range? Is there kind of a bimodal distribution? And all of these insights are really important as we think about both kind of explaining a data set to non-technical stakeholders, but also thinking about kind of the more exploratory data analysis side, where we're just trying to get a handle on the data set so that we can approach it more effectively from like a predictive modeling slant or something like this. So let's do all of these. So remember, we basically have like 4 types. We have histograms, old school, boxplots, even older school, scatterplots, and then density plots or heat maps. So we're just going to walk through each one of these 4 and see how it goes. So the kind of downside is that at least with histograms, it's not super obvious right off the bat how you would do this. So we're going to drag life expectancy female, although you could do really any numerical variable you wanted, into our rows. And then we're going to go over to this menu on the side here, this show me. So show me is giving you a list of options. So basically think about this as the menu that Tableau allows you to kind of choose from. And the ones that are highlighted are the ones that are reasonable given the variable types that you've added to various shelves. So here we have one numerical variable, and it's Tableau saying if you have one numerical variable, you can either use a horizontal bar chart or a histogram. So we're going to make our histogram here. Get rid of the show me. Now notice, and it's kind of easy to miss at the beginning, we have a new variable here called life expectancy female bin, and that's these bins down here. So what Tableau has done is gone through and converted life expectancy female from a numerical variable to a categorical variable, and that categorical variable has values that represent bins. So there's a 46 to 50-ish, whatever, 50-ish to 53-ish, whatever, and so on and so on. And then it has counted, so notice that the rows here are no longer the life expectancy female, it's actually the count like we had before. Now, we could change this like we did in a previous video to percentage of total. We have all the same options we had before. The one I want to point out right now is what do we do if we want to change the bin size? Because that's really the critical issue with histograms, is how wide are those bins? How granularly am I thinking of the data? Am I grouping lots of things together, or am I thinking about things on a much more individual basis? So to change this, I go to that new variable. So not life expectancy female, but the bin version, which is up here in our dimension area. And I do my little menu, and I say edit. And here I can say my bin size. So let's just say 1. I don't know, whatever we want to do. And we can really change the histogram quite a bit. Now, the bin size, it's tough. It really is tough. I mean, it's like I mentioned previously, one rule of thumb is to use the square root of the number of data points as a reasonable bin size, or I'm sorry, reasonable number of bins. But it's just a guideline. I mean, it really is up to you to pick this thing. You don't want it to be too small because you want to group like things together. You don't want it to be too big, or you're lumping too many things together. So it's a tough one. It really is kind of a tough design decision. So this is basically histograms. That's it for right now. So let's move on to boxplots. Remember, boxplots are even older, but remember in a boxplot we're showing quartile information, so Q1 and Q3, and the median, which is Q2, and then those whiskers that are showing us like reasonable ranges of variability. So let's do the same thing. We'll do life expectancy female. We're going to drag it up to rows, and in this case, if we do the show me, we don't have the option. Here's the box and whiskers plot. What's the deal? Well, we need multiple data points to do this, so let's drag country region onto detail. If we do this then, and I go back up to show me, it says, okay, good. And notice what I was saying earlier. It's saying, you know, you need at least one dimension and blah, blah, blah. So it's now saying, oh, I can make a box and whiskers plot out of this. So we click it, and here we go. So notice that 2 things. One, this axis is screwed up. Like, it's not reasonable for people to have life expectancy of 700. So again, we're going to change the aggregation here. We'll say measure, and instead of sum, the average. So now this is the average across each country for all years. And just to remind ourselves what's going on here, we have the median in the middle, and so and the median here is 75-ish. We have the upper hinge, which is 79. We have the lower hinge, which is 65. But again, the lower hinge is Q1, the upper hinge is Q3, the middle is Q2. So 25% of all data points fall below here, 25% fall in the dark gray region, 25% fall in the light gray region, and 25% fall above the light gray region. And this is one of the reasons that Boxplots are actually really useful. These data points are so stacked up in here. It does not look to me that 25% of the data points are in this region, but they are. They're just so stacked on top of each other. Those marks are stacked on top of each other that it's very difficult to discern that. That's why these Boxplots can be so handy. So notice here, I have one outlier, Sierra Leone, and that is, I'm calling it outlier because it lies below the whisker. And these whiskers are 1.5 interquartile ranges. Now, you'll notice that this one is much longer. By convention, you don't extend the whisker. You extend the whisker out only to the last data point that's within the range. And so if there's no data point all the way up here, we just stop the whisker. And so that's why this whisker is shorter than this whisker. We could also break things down by region, for instance, have one of these per region by dragging region to columns, and now we kind of have kind of a different flair to it, and we'll talk more about kind of what that might be useful for, but just to point out that we can spice these things up if we want to. So these are both for univariate, meaning there's only one variable displayed. We have life expectancy in histogram form and life expectancy in a boxplot form, but what if we want to do multiple different types of multiple numerical variables together. So this brings us to scatterplots and to density or heat maps. So let's do life expectancy female as our columns. Let's do rows, just to stay consistent with the slides. And then birth rate as our columns. So here we have one point, and this point represents the entire world. But this is not what we want. We want 1 point per country at very least. And again, we have the same issue here where these axes are not meaningful because these are summed. So we're going to change these things from sum to average. And again, we'll spend a whole week talking about this thing. So here we have our scatterplot. So it's clear that these things are distributed together, and even that they have a relationship with one another. And we'll talk more about that when we talk about trend lines and all of it. But clearly, this is not kind of a blob distribution. This is not a tight line. There's a kind of a skewed distribution to these things, and the only thing that's left a little unclear is, there are so many marks up here that are stacked on top of each other, and this area is much sparser. It would be nice if there were a way to show kind of which areas were hot spots or highly dense in terms of the number of marks, and which ones were less dense. To do this, we just go here to marks, and instead of allowing it to choose automatically, and it chooses automatically the scatter plot, we just go down to density. Now this density is pretty neat, actually. I mean, it really does help show that this is a much denser region, and users still can in the tooltip see individual countries. But it's a little bit handier in terms of being able to show that some regions of the space are much more populous than others, even though the marks are going to crowd on top of each other. So these distributions are mainly geared to understanding what you're dealing with, kind of what do we actually have, and that is always a springboard to other things, whether that's a modeling effort, or in this case, we've now seen that there's an interesting distribution of birth rate and life expectancy. And our next step might be to more rigorously understand the relationship between those two variables, which is another video in this series. But all in all, like these simple plot types are often just a way of organizing our thoughts and seeing if there's a phrase that I love, seeing whether there's a there. Is there anything there worth investigating? And if you look at something and say, there's nothing there, there's no there, then we're done. But if you look at something and say, there's something there, that's really interesting, and it's worth taking a look at. So in future videos, we'll take a look in a much more detailed way at these relationships, and obviously much more detailed across the board in terms of how we might model and approach these things.